exponential type questions, expressions, you cannot have negative exponents in your final answer. Just so you know, that would not qualify as being simplified. So they may show up. You got to then follow that up and take care of those. You cannot have common basis. So like the letter x, the variable x, could not show up more than once in the final answer. And 90% of the time, parentheses should be gone. So no parentheses. No common bases. That's the no variable showing up twice. No negative exponents. I think I hit it all. Raise your hand if you are done with all four. Raise your hand. Keep your hand up. Raise your hand if you are as far as you're going to get on all four. Okay. Where did you get stuck? Bailey? Number 4. Did you make a first move or no? No. Who can share with Bailey? There's a couple different ways I could start this one. Who can share with Bailey how you started it, and then we'll see if anybody has a different option. The negative on the outside of the fraction can just flip everything. So in other words, one option is to eliminate that negative exponent on the outside first, just by flipping it, and now rather than being a negative 2, it's a positive 2. That does work. Did anyone do anything different? No? Okay. What you could do is you can immediately raise everything to the negative second power. In doing that, though, obviously you're really spreading out this negative exponent issue, but you can, like 5 to the negative second. I wouldn't make that a fraction yet because you'd have a fraction within the fraction, also called a complex fraction, which I don't really want to deal with. X to the negative second and y to the negative eighth. Then you individually would deal with all those negatives. So here's where everything would flip because everything's negative. But if we went this way, now what did you have for your final answer, Abby? Y to the 8th over 25x squared. Did anybody have anything different? Okay, that is correct. And Abby did a nice job of remembering to square the 5 because that's a common mistake. Nate, where'd you get stuck on? Which problem? Under 1. Yeah, and then you created a complex fraction by doing that. So when a fraction is raised to the negative exponent, it's just easier to flip it. 1 over a fraction, by the way, does mean just flip that fraction. So it is the same thing, but yeah, complex fractions kind of adds to our confusion. That was the same one, though, that you got stuck on? Anybody get stuck on 1, 2, or 3? All right. Aiden, what did you get for number 1? Final answer? Say it one more time. Y to the 24th? Sorry, it's hard for me to hear with that fan. Is it hard for you to hear me with that fan? To hear me? To hear other. So when we get called on, you got to use your teacher voices. Did anybody get anything different for that one? You got to speak up or else you're going to miss a learning opportunity. Math by majority. I'm not going to check your work. If you all got that, then we just are going to assume that that's the right answer. Number 2. Connor. Where's Connor? Connor? Negative 18x cubed. Y to the 6x squared. Is that what you said? I didn't hear the minus, I'm sorry. Minus 6x squared. Did anybody get anything different? Don't be shy about it. What's your first name? Mackenzie, what'd you get? Just that? Anybody get anything different? Abby, you look like you want to say something, but you're nervous.
I got
the second one?
Yeah.
The second one is correct. Who can comment and tell us what we think Connor might have done wrong? Marissa. Kind of foiled it. Did you do that? Did you distribute your -6? Distribute an x squared? Foiling is reserved for polynomials, right? And although this is a complex monomial with multiple parts, those parts aren't separated by pluses and minuses. So they're not separate terms. So this is just a monomial times a monomial. So you made your life just a lot harder. And that is correct. With a monomial times monomial, your constants get multiplied, your x's get multiplied, your y's get multiplied, and you all obviously have been adding exponents accordingly. So that's good. Okay. And number 3, Trista. And x what? 5y to the 6 over x to the 4th. Anybody get anything different? Raise your hand if you agree with Trista. Math by majority. Good. Okay? So, definitely a review. The properties down below, okay, just all with variables, so these are just the rules. X to the -a would become 1 over x to the a. X to the 0, Andrew. 1, very good. X to the a times x to the b, what would that look like, Bridget? X to the a plus b, very good. That's your common bases rule. Looks like my old hole punch knocked out my D. X to the a to the b, John? X to the a times b. If you want that multiplication symbol, you can. Otherwise, x just to the ab power. Julia? E?
X to the a.
Very good. Mitch? Very good. X to the a, y to the a. And lastly, Morgan. Excellent. And you know what? Now that I see it, that's where I should have written the other stuff that we already wrote up above. Okay? So that's all review. Scientific notation is certainly review. Although, did you do it last year? If you did, you probably forgot, because it's not usually a topic that we keep spiraling through Algebra 2. Who wants to take a raw stab at it? How about Olivia? Did I leave off with you, Olivia? Did I just leave? No, I left off with you, right? Okay, Olivia, go ahead. Anybody disagree? Okay, that's very good. 5.21 times 10 to the 9th. And on B, take a minute. Sarah, what do you think? 6.093 times 10 to the negative 7. Does anybody disagree with that? Oh, you got a couple fighters. Good Joe, right? She just forgot the negative out in front. If it's a negative number, that's going to be a negative. If it's a positive number, that's going to be a positive number. Sounds like, at least just by random check, that you guys remember this. The key features are that the base number here has to be between 1 and 10. Positive 1 and positive, well, 9.999 technically. Or between negative 1 and negative 9.99999. This number has to include all non-zeros that exist. So like we were not able to get rid of that zero simply because it was sandwiched between some non-zeros. And then the exponent tells us, if we're moving from scientific, it tells us move it, if it's positive, move it right 9 units and fill the blanks with zeros, which puts you at that. And if it's negative, move it left. One thing, just to, if you're ever unsure if it's positive or negative, because it depends, obviously, if you're going from this direction to here, you moved it left, but if you're going from here to here, you're moving it right. So generally, if it's a positive exponent, it should be a gigantic number, and if it's a negative exponent, it's a teeny tiny decimal. Pretty fair? Okay. All right, so this just might be a little new, and we're going to encounter a twist on here that you need to be mindful of. This is like one of those places where I would say Algebra 2 and Pre-Calc might as well be the same course, but there's a couple little things that will come up that we got to stress, like don't miss this little fine-tuning detail, and one of them is going to show up right here. So if you wanted to multiply two numbers that were already in scientific notation, you just multiply their bases, and this would become 35.5. Now, here's an example of something I would expect you to do in your head. The 7 times 5 gives you the 35. The 0.1 times 5 gives you the 0.5 without having to write that out, okay? So that's 35.5 times, and then with the tens, we're going to kind of follow our exponent rule. 10 to the 5th, 10 to the negative 7th. When you deal with your common bases, that's going to become 10 to the negative 2nd. Now here's the glitch. That's not okay. That's not proper scientific notation. Why not? Who can tell? Abby. Right. This is not a number between 1 and 10, like it's supposed to be, 1 and 9.999. Okay? So here's the question. I know I have to move this 1 to the left, so it's 3.55 times 10 to the, is that going to change my negative 2 exponent one direction to the negative 3rd, or one to the other direction to the negative 1st? That's the tricky part that we just have to figure out. So take a minute and we'll take a vote. Is this going to be a negative 3, or is it going to be a negative 1? There's going to be 3 options. You're going to hold up 3 if you think it's a negative 3, that it should be. You're going to hold up 1 if you think it should be a negative 1. Or you're going to hold up a fist if you are going to own the fact that you have no idea how to tell. On your mark, get set, go. No fists. That's good. And the other, I can't see you over there. Okay. It should be a negative 1. Okay? So if you kind of go based on, should I move it left or right? Like, that's not really, I don't like to wrap my head around it that way. I just think about it conceptually, and you guys can share with me if you have another strategy. But I'm thinking, okay, in standard form, I would need to move this 2 units to the left according to that negative exponent. So it should be 0.355 when it's in standard form as opposed to scientific form. So if I needed the decimal essentially to be in front of the 3, here I had to move it 2 to the left. So once it's already here, now I only have to move it 1 unit to the left. So that's just how I conceptually think about it. Anybody think about it differently than that? So you all thought about what it should be and then went that way. Good, okay? In B, again, no calculator. When you guys see 1.2 divided by 3, I'm sure your initial reaction is, I can't do that without a calculator. Who thinks that? Do you think that, Julia? Yeah? Julia, do you know what 12 divided by 3 is? 4. So see that as 12 divided by 3. But if 1.2 is being split into 3 parts, it's not obviously going to be the whole number 4. It's going to be 0.4. See that? Just a technique. So this is 0.4 times 10 to the what? Joe? What'd you say? To the 9th. Because we're subtracting, common base is being divided. 6 minus negative 3 is to the 9th. And again here, this is not proper scientific notation. Because 0.4 is not between 1 and 9.99999. So take a minute and decide what you think that should be. Mackenzie, what do you think? What's the base number? 4 times 10 to the 8th. Anybody disagree? Yeah, and you think it should be 4 times 10 to the 10th. So, what was your logic? Well, so here's my thought. When you raise it to the 9th power, you're supposed to move your decimal place 9 units to the right. If you move it 1 decimal place to the right already, now you actually only have 1 less unit than you used to move it to the right. You follow? So when you make a rule about this, like always increase the exponent by 1, or always decrease the exponent by 1, or if you're moving it to the right, that like a rule about this, there's really 4 different rules. It's almost harder to keep track of. I would say logically think through it every time. The less I'm not a big like memorize person. If there's an equally as quick way to just think about it conceptually and logically, I would say just do that instead than trying to, and I know a lot of you don't work that way. You want quick and fast rules that you can just memorize and follow. But I think here it creates more of a disaster than it helps. So, any questions on that? So in general, we talked about this already. This is just going to define scientific notation with that kind of more mathematical language. So scientific notation always has to be where the absolute value of A, so the absolute value of this number is always, what numbers would go on either side of this inequality? Who thinks they could fill those in with the appropriate numbers that the absolute value of A has to be between? when I've continuously been saying this, I keep saying 9.999, but pay attention to the signs on either side. We can be equal to 1, but we have to strictly be less than 10. Yeah. When I've been saying it, I've been saying up to 9.999, but, and truthfully, if I put a less than or equal to sign there, I would have to use 9.9 repeating. Good. And where n has to be an integer. Okay? So where n, such that n is an integer, or that could also say n is an element of the set of all integers. You can't have 10 being raised to a decimal power. It has to be an integer. Okay? So nothing overly, and you're going to find this as we kind of work through pre-calc, nothing is going to knock your socks off. It's all going to be slight adjustments from last year. What might knock your socks off are like the different styles of the tests, but we'll get there. So because we have time, don't we? 10 minutes, 9 minutes? Yes? I'm going to show you from the review sheet what applies to today. And I'll have you work on it. Number 17. Take a minute and do number 17 and 18. Now, on 18, I will tell you 2.8 times 3.9 is a little ridiculous. There's no mental math there. So I'll just tell you what that is. What did you say? Oh. Could you tell I couldn't find it? I was going to go grab what the Thank you. 2.8 times 3.9. 10.92 for 18. When you get there, I'll just write it on the sheet. Oops. If you're finished and just kind of looking at it, 19 and 20, you'll see that's stuff that you should know how to do already. We'll review it, obviously, within the next chapter if it's on the review sheet, but raise your hand if you're done with both. Very good. Is it Nate? What did you get for the first one? 8.6 times 10 to the negative 7. Anybody get anything different? Okay, that one was pretty easy and straightforward, right? No adjusting. The key comes with the adjusting. And on 18, Sarah, what'd you get?
1.092 times 10 to the 29.
Anybody get anything different? Good. So, well, we'll see if it's good. I'm sure it is. If math by majority, we all agree with her. 10.92 times 10 to the 25th. And then that means we have to move it 25 units to the right. Well, unfortunately, to get it proper, we have to go against the grain a little bit and move it one more additional one to the left. So that's counterintuitive to the way we were supposed to be moving it. So in that kind of situation, we've added on to the number of units.
With seniors at this time, please make their way out to the football field for the panoramic picture. Please go out through the gym doors and across the crosswalk, please. And seniors out to outfield at this time.
Oh no, there were more, but nothing that we know how to do. Okay, so that's the end of that. We have 5 minutes.